Well, so in this class, we are going to discuss types of biotelemetry based on type of channels we are using. Okay, so the thing is, the importance of studying this type of telemetry is very important as far as medical field concerned. The reason is that we are not in medical, we are not diagnosed, or we can't do treatment just to have one physiological data. We have to go with the multiple physiological data, many physiological data in order to assess any kind of problems. Okay, so it arises the demand of acquiring or analyzing or monitoring or transmitting the n number of physiological parameters compared to the single parameters. So that is the reliance. Okay, that is the dependency of more than one physiological parameter is very much important as far as the medical concern in order to do any kind of treatment or diagnosis and so on. So that is the reason, especially in case of biotelemetry, that in wireless case, we are not having only the single channel telemetry system, we also have a multi-channel telemetry system. So wherever the need arise, there is a demand to monitor, or there is a need of having two or three biological parameters, so in that case we have to go with a multi-channel telemetry system. The concept and everything is very easy. It's the same like a single channel. If you see, only the difference between single channel telemetry and multi-channel telemetry system is the input side. Because in input side, if you are using only one signal channel in order to measure only one physiological parameter, means that is a single channel. If you are using a multi-channel, means you are going to have different n number of channel in order to record or get the signal of n number of physiological parameters. Okay, so since because of this difference, the addition of block is also that is the one more addition of block, because of increasing number of channels. That particular block is that mux. Okay, that is multiplexing. Okay, so if this single channel, there is no need of combining all the there is no need of combining the signals, because you are just having single channels. Signal in single channels, you are going to anyway get single output only. So that signal output, you are doing some kind of modulation in order to transmit. So after at receiver end, you have again demodulation circuit for that particular signal, so that you are retrieving or extracting the original information that will be displayed in the end device. This is what happening on the single channel. Okay, but in case of multi-channel, each channel, okay, if you see this, this is the block diagram of a single channel. So one signal input, you have a set of blocks in order to conditioning that signal. Okay, see now if you see the multi-channel, the multi-channel is something different, because in multi-channel you have, for example, if you have a three channels, so the three channel is going to carry the three individual input signals. Okay, each individual input signals, like one is heart rate, one is bp, one is pulse rate, in the sense each individual signals are equally important. It has to be equally treated. Okay, so so that the set of blocks, whatever we discussed in the basic block diagram, that blocks have to be included, or you have to be used for each and every set of channels. Okay, if you are using heart rate, means for the heart rate signal, you need to you need to do some amplification, you have to need modulation. If there is a demand arise, you can do some kind of other processing also. But similarly for other two set of signal also, you have to have individual processing blocks. Okay, so once everything is combined, you can't transmit the signal everything as a channel. Okay, so you have to combine all the signals in a single manner. So here comes the picture of frequency division multiplex system, or time division system. So these tools are classification of marks. The classification of the importance of mux is, as I said, the mux is going to combine all the signals and give it back into one single signal. Dmux means again, so again we have to extract the original signal, right? You have to recover the original signal. So in Dmux, what it will do means, if if you are giving one input signal, it will give it as a three set of signals. So as like it as such as like your original signal. That is the process of mux and demux. But the thing is that what type of mux you are using, that is the other important question. If you are dealing with analog signals, then you have to go with frequency division multiplex. Okay, not only frequency division, you have amplitude, and you have also have a mux code multiple multiplex system. If you are dealing with digital signal means, then you have to go with time division multiplex system. Okay, so the difference is that, for example, if you see the frequency type of multiplex, the one well known example is that you have telephone conversation. Okay, so based on your sound frequency, the carrier's frequency will get varied accordingly, and then it's getting transmitted to some distance. Okay, so that is the your frequency signal. If it is a digital signal means, you have a different time slots. Okay, so first you have a different time slots, you have it some time frame, and you are having slots, different time slots for the different channels. If for example, if you are having first slot of timed for heart rate means, then second slot will for BP, and third slot will be for pulse rate. Okay, so the first these according to this time slot, one channel will get activated at the time only. One according to that, the channel will get activated, so that one set of cycle is get completed. So in one set of cycle in cycle, you will be having BP, heart rate and pulse rate, and then again the cycle is get repeated, again you will have the signal of BP, heart rate and pulse rate. So similarly, you will having you are combining all three signals in terms of in signals as a single signal at different time slots. So this conversion will be transmitted by means of some transmitter, by changing carrier signal, and then you have a receiver end where you have a receiver demodulator. You are there you are demodulating signal, again you hear there you are having a different time slots. Okay, so see, this is the block diagram. We have again different time slots. According to that, your first your BP signal is getting retrieved, and second one your heart rate signal is getting retrieved, and third one is your pulse rate signal is getting retrieved. So similarly, these three signal is getting required, and as a result, you will be displaying both three signals simultaneously in the end device. Okay, so this how the time division multiplexing is working. Okay, for transmitting the multiple signal in one single signal, and then again in receiving end, receiving the one signal, and again retrieve back into three set of multi signals. So this how the whole setup is working. So that's all about the biotelemetry. So in next class, we will catch up with different catch you back with different topics. Thank you.